Most sales data is messy, transactional, and hard to report on, unless you are a data engineer. But today, I'll show you how to use AI to design the perfect data model for reporting, and then use KNIME to automate the transformation forever. You'll go from raw data to smart, reusable insight, even if you're non-technical. This is what real transaction data looks like. The transactions data in a database is usually stored in a format that's not easy to build direct reporting out of, which means answering basic questions like what were weekly sales by region and category, what's our profit margin trend, or which categories are discount heavy, requires you to clean, calculate, and reshape everything over and over again. What if we didn't have to start from scratch each time? I asked AI to help. Here is a transcript of my conversation with AI. I asked, "Hi, I have 3 tables from a retail sales database, transactions, products, and stores, and I gave AI the columns that were part of these 3 tables, and I asked, I want to create reports that show weekly sales performance by product category and by region. How should I transform this data?" Now, AI said that to make the reporting easier and faster, I should be doing aggregation and creating an aggregated reporting table that aligns with my business questions. And this is what it gave. So I need to create a target table for a weekly sales summary, which includes a week start date, region, category, total units sold, total revenue, total discount, total cost, total profit, average unit price, and profit margin percentage. All of these metrics, starting from total units to profit margin percentage, are calculations that I'll need to perform on the raw transaction data. And AI also gave me the steps to transform the data from the raw tables to my reporting table. So it's asking me to join transactions with products on product ID, and then join with stores on store ID. Then calculate revenue, cost, and profit, and then finally group by using week start date. A requirement for week start date is that we have to extract the week start date from the transaction date column in the transaction table. And finally, we perform some aggregations on quantity, revenue, discount, cost, and profit. We calculate the average unit price and we derive the profit margin. And I continued my conversation by asking more questions, and AI continued to give me a design of my reporting tables. And finally, I asked, how can I build this in KNIME? And AI also gave me the steps that I could follow in KNIME to build a workflow that transforms the raw data into my reporting table, which can answer the business analytics questions that I'm trying to answer. So as a summary, I asked how to report sales weekly by region by category, and AI gave me a full reporting schema with calculated KPIs. And when I asked what should I group by, it gave me weekly date, region, category, and how to calculate margin, revenue, cost logic. And when I asked how do I do this in KNIME, AI gave me a step-by-step workflow outline. Thus, we are using AI as a thinking partner to help design a business-aligned data model. Let's now switch over to KNIME and build this workflow. Okay, the first step in the workflow is to read in the raw tables. In our case, that's the products table, which has the information about the products like name, category, brand, unit cost. Then we have the transactions table, which has transaction ID, product ID, store ID, quantity, unit price, transaction date, and so on and so forth. And finally, we have the store table, which gives us details about the stores. Going back to the transaction table, if the transaction ID is the primary key for this table, the product ID and the store ID are the foreign keys, which helps us join the transaction data to the products and the store data. So let's first join transactions with products. I'm going to join the transactions with the product data using product ID as my joining criteria. I want matching rows and I want to include all the columns from the product table except the product ID because that already exists in my transaction table. And for each of the 10,000 rows in my transaction table, I now have the product information that aligns with the product ID in each transaction. Next, we are going to join the store data. So our joining criteria in this case is going to be store ID from the transaction table and the store ID from the store table. Again, I want matching rows, and in my columns, I want everything except the store ID from the store table and everything from the joined table that I have so far. So now we have a fully joined raw data which includes 15 columns, and I have for each transaction ID products information, store information that I can use for my further KPI calc. The next step that I'm going to do is I'm going to extract the week number for each transaction. To do this, I will first use a string to date time node, and I will convert the transaction date to a date column. I'm going to change the data type of the transaction date, which is currently string, to a date data type. I will use the auto guess format and I will apply the change in the data type. So now, previously, before this conversion, transaction date was a string data type. You'll notice string mentioned here saying that transaction column is storing the date in the string data type, but now we have changed that to transaction date being a date data type. The next step is to use a date time part extractor and get the week number out of this transaction date. So date and time part extractor node will help us to analyze the transaction date column. We will add a week column. So this will extract the week number from the transaction date. When I click apply and execute, you will see that now we have two extra columns. One is year and one is week. So for each transaction date, we get the week number that the date corresponds to. Our next step is to perform the KPI calculations. For this, I am using an expression node which in KNIME version 5.5 replaces the column expressions node. Let me expand this and let me calculate some metrics here. First thing, we will do unit price multiplied by quantity to give us revenue. Next, I'll multiply unit cost with quantity to give us cost. Next, I will multiply. Next, I'll calculate profit by subtracting cost from revenue. We call this profit. These three calculations in place. So KNIME has applied the expressions for all of the rows. The next step is to now perform some grouping and aggregation. As a first step, we are going to group the data by week, for which I will use a group by node, and my group column is going to be week. In manual aggregation, I am going to find out the sum of quantity, sum of revenue, sum of cost, and I want an average of unit price and a sum of all the profit. So the group by node has aggregated the data by week. So for each week, it shows us how many units were sold, what was the total revenue generated, what was the total cost of the products for the organization, what was the average unit price, and what is the total profit generated for the week. Let's rename these columns so it helps with reporting. So I'm going to use a column renamer. My sum of profit is total profit, mean unit price is average unit price, sum of cost is total cost, total revenue, and finally sum of quantity is total units sold. So now we have a cleaner table with columns named appropriately for the KPIs that we have calculated. Finally, I want to now calculate the profit percentage for each week, and I will use an expression node to give me the result. So my profit percentage is total profit divided by total revenue. Let me multiply this thing by 100 and we'll call this profit percentage. For now, for each week, it shows out of the total revenue, what is the percentage profit that the business generated. We repeat this process for product category and region. So we performed aggregation and KPI calculation by week, by category, and by region. This helps us answer the business analytics questions that help us get a good summary of the sales performance. Finally, we can look at this data in a presentable format using the table view nodes, and we can export this data out to an Excel format or pipe this data into Power BI if need be. We want to export all the three summaries into the same file, and so I'm using a variable called file path to make sure that all the three data summaries are exported into the same file as three separate sheets. And let's take a look at the final output. So you'll see that we have our sales summaries by week, by category, and by region, thus helping us make sense of the sales performance of this organization. Here is the magic. You just didn't clean data. You codified a reporting mindset into a KNIME workflow that can run anytime with new data. AI helped you think like a data modeler. KNIME helps you run like a data engineer, and you stay focused on decisions, not data prep. This is what I mean by design once and automate forever. If you want to learn how to think like this, to use AI and KNIME not just for tasks but for transformation, reach out to me to know more about my coaching program. I teach business analysts and aspiring data professionals how to design smarter, automate confidently, and grow their careers. If this video helped, hit subscribe and let me know in the comments below if you have any feedback for me. If you wanted to see a particular business analytics problem solved using KNIME, let me know in the comments below. Thank you for watching.